All right, here's another system. This problem's different, of course. You're going to actually have to graph this one, both these equations, the system, and then see if you can find the solution to this system. 1 minute, go. All right, well, let's solve this system by graphing then. Now, neither of these two equations are in slope-intercept form. And in order to graph the line, we do need them in slope-intercept form. So let's go ahead and start that out. And I'll start with the x minus y equals 2. So to change this into slope-intercept form, I would have to subtract x. If I do it to one side, the principle of equality says I got to do the other side. Why subtract x? Because then it zeroes that x out, makes it a phantom zero. So now I have negative y equals negative x and plus 2. Again, the 2 and negative x, I can't combine those because they're not like terms. Well, the coefficient of y there, I'm going to show that phantom 1. And I need to get rid of it or make it a phantom positive 1. So I'm just going to divide it by itself. But if I do it there, I got to do it to all the terms by the principle of equality. So that makes that a phantom 1y. So now in the coefficient of x, that's negative 1 divided by negative 1, which is positive 1x. And 2 divided by negative 1 is negative 2. Now the coefficient of x1, I'm gonna make it 1 over 1 so I can see the rise and run. So I can see my slope, 1 over 1. And that means, since it's the 1 in the numerator, since it's positive, that means I would go up 1. And then the 1 in the denominator is positive, so I would go to the right 1. Up 1, to the right 1. And then I need my y-intercept, which is just that negative 2 right there. But remember, it's an ordered pair, so make sure it's 0, negative 2. So I put this ordered pair first on the graph, and then I'll use the slope to find all the other points. All right, so 0, negative 2 would be right here. And from there, I'm just going to use now we're going to go up 1 to the right 1. That's better. So up 1 to the right 1. What's this next point? Up 1 to the right 1. Up 1 to the right 1. Just continue this pattern as far as I can go on the graph. Up 1 to the right 1. Up 1 to the right 1. And we get all these points. Okay. I can go the other direction on the graph also. I'll just go, instead of up 1 to the right 1, I'll go left 1 and then down 1. See how that makes that same stair-step pattern, which is what we want. Left 1, down 1, left 1, down 1, left 1, down 1, left 1, down. So that was a lot of points to put on the graph, no problem. Now, before I draw the line through these points, I'm actually going to make the other line first. Okay, so I will draw the line. I'm just going to wait. And the reason why I'm waiting is because in this unit, when we're graphing, we shouldn't see any fractional or decimal values in the ordered pair that is the solution to the system. So we shouldn't expect any funny business like that on these problems. Now, when you get into 9th grade and you're solving systems with other methods, yeah, you'll see fractions and decimals. That's okay. But while we're just graphing right now, we shouldn't see any. So I'm going to take this second equation, which I'm gonna do in purple, and I'm gonna change it into slope-intercept form first, right? So x plus 3y equals 6, and I need to get rid of that x, so minus x from both sides. I'll zero that out, drop the 3y, and we can see that we can always change an equation that's in this form into slope-intercept form in 2 steps. So the negative x and positive 6 I cannot combine because they're not like terms. Now divide all the terms by the coefficient of y, which is 3. To make it a phantom 1, 1y, now I'm going to show the phantom 1 for the x, negative 1. So that's a negative 1/3 x, and then 6 divided by 3 is positive 2. So just from that equation, I can see my slope, m, is negative 1 over 3, and the negative tells us we'll go down 1. And the 3 being positive tells us we'll go to the right 3, rise over run. So rise is up and down, run is left and right. And then we have the plus 2 right there, which is the y-intercept. Again, that's an ordered pair at 0, 2. So I'm going to start with the y-intercept on the graph at 0, 2, right here. And then I'm going to use the slope to find all the other points. So that would be down 1 to the right 3, which is this next point. Down 1 to the right 3. Down 1 to the right 3. And you can see we've already found the point of intersection, where it's purple and red. But I'm going to continue to graph this line because I think it's good practice. So I was going down 1 to the right 3, so now I'm going to go left 3, up 1 to continue the stair-step pattern. Left 3, up 1. Left 3, up 1. And so I have all these points. And yeah, we can see the point of intersection between the red and purple lines. Once I draw them, it'll be this point right here in green. And what is that ordered pair right there? It appears to be the ordered pair 3, 1. So that is the solution to the system. But before we finish, I'm going to draw the line through the points. So there's the red one. And then we got the purple one, something like this. Okay, so again, if you checked, if we went back to the two equations, and you check 3, 1, right? So you'd say in the first equation, x minus y equals 2. I'd replace the x with 3 and the y with 1. And I see 3 minus 1 equals 2, so that would be true. And then in this equation, if I replace the x with 3 and the y with 1, that would make 3 plus 3 times 1 is 3. So 3 plus 3 is 6. And it also makes that second equation true as well. Which it needs to do in order for it to be the solution to the system. It has to make both equations true, not just one. Definitely not neither of them, but should be both. The only thing that's really new that we've seen so far is just that now we're graphing 2 lines instead of 1. Hopefully that's not too bad because we've been doing this now for about 3 months.